Okay. When I say multiplying and dividing rational expressions, you say, huh? Say what? What's a rational expression? Well, I'm going to tell you. A rational expression is a ratio, which would be a fraction, that has two polynomial expressions in it. So, remember, a polynomial can be a monomial, which is one term. It can be a binomial, which has two terms, like these examples. Trinomial, or even bigger, which we would just call a generic polynomial. I'm just trying to raise that.
What section?
9.1. We will have a test in here on Friday, section 9.1 and 9.2, which is going to be taking these things, multiplying, dividing, adding, and subtracting. Okay? There are three steps that we're going to be doing today. We're going to be simplifying rational expressions, which, remember, if there are fractions, we always want to reduce them, right? Well, we'll call this simplifying, and here are our three steps. First, we're going to factor anything that can be factored, which requires us to remember our ways of factoring. What's the first thing that we should always look for when we're factoring? A greatest common factor. Another way of factoring is grouping, which we're not going to see much of that here. We're going to see greatest common factors, we're going to see the difference of perfect squares, and we're going to see a lot of trinomials. All right? We're not going to see much on cubes and grouping. But those are your three most common. GCF, difference of two squares, and trinomials. After you factor, you're going to put restrictions on your variables. Now, we did this before this year. When you have fractions that contain variables, why do we restrict our variables? And which variables do we restrict?
They can't be 0.
Okay, which ones can't be 0?
A negative.
The denominator. We need to place restrictions on the variables to make sure our denominator does not equal 0 because that's undefined. Okay? You restrict before you cancel. So we're going to factor, we're going to find our restrictions, and then we're going to cancel all the terms that can be canceled. All right? So in three simple words, factor, restrict, cancel. Say it with me. Factor, restrict, cancel. All right, if you look at this first example, you have 2x times x minus 5 over x minus 5 times x squared minus 1. Factor, restrict, cancel. Is anything there that can be factored? X squared minus 1. What is x squared minus 1? It's the difference of two squares, and it factors down to x plus 1 times x minus 1. Okay, so I have factored it.
You gotta get a, like if there's any exponent ever, you have to do that?
Yes, unless it's just completely by itself on the outside. Okay, now, factor, restrict. We only restrict the denominator variables, the ones in the denominator. So, in this first term here, if we have x minus 5, what can x not equal? Positive 5. In the next term, x cannot equal? Negative 1. It can also not equal? Positive 1. So we can simply say plus or minus 1. X can equal 0. X itself can equal 0 because this will still render me a number, as would this and this. Okay? He said x can't equal 0. X individually can be 0 because that would be negative 5 times 1 times negative 1, which is just 5. Okay? Anytime x is being added or subtracted, your restriction is going to be an actual number other than 0. If x is by itself, say like this, if that was in the denominator, then x cannot equal 0. Because 2 times 0 would give me 0. All right, so we factored, we restricted, now we're going to cancel.
Just restrict in the denominator?
Just the denominator. We don't care if the numerator equals 0, that is a number. What groups are alike? X minus 5 and x minus 5. And all you have left to do is write what's left. In the numerator, you have 2x left. Sort of. But we're gradually getting harder. Okay? We're starting easy and we're gradually getting harder. Factor, restrict, cancel. God bless you.
Which one's the answer?
This whole thing is the answer. It reduces to this fraction as long as x is not 5, 1, or negative 1. Okay, here's another example. A plus b divided by a squared minus b squared. Understand, even though parentheses aren't present, these are groups. Okay, and unless the whole group can cancel, nothing cancels. Step 1, what can be factored? A squared minus b squared can be factored. All right, so my numerator stays the same, but my denominator becomes a plus b times a minus b. All right, so we have factored. Next, we need to restrict. Okay, how do you restrict when there's more than one variable? Just pick one variable and restrict that one, and it automatically takes care of the other one. So if I say, what can a not equal?
0.
A can be 0. A cannot be negative b. If this was a 2, we'd say a can't be negative 2, right? So if it's b, then a can't be negative b. It can also not be positive b. I do not want this expression to equal 0. So if I subtract b from both sides, I do not want a to equal negative b. Because negative b plus b gives me 0. And 0 times anything is 0. Positive b minus b gives me 0. And 0 times anything is 0. Okay, what can cancel? A plus b and a plus b. Now, if everything in the numerator cancels, what's left in the numerator? A 1. It does not magically become a whole number. Just like 2/4 reduces to 1/2, it doesn't reduce to 2. Okay? There's a 1 left in the numerator and a minus b in the denominator. Simplifying rational expressions. Which means we need to be really good at doing what? Factoring. Okay, now I want you to pay attention. Don't write this down. Just pay attention. If I have, because what we're doing here is we're trying to cancel things that are the same, like a plus b, right? They've been looking identical. Now, if I have 3 plus 1 over 1 plus 3, the order is different, but is that the same thing?
Yes.
Yes, because they're both 4, right? And so they can cancel, and the answer is 1. And just the same thing here, 2 plus 9 over 9 plus 2 is 11 over 11, which is 1. Okay? Which means if you're faced with this, is that not the same thing? X plus 3 times 3 plus x is the same thing. So we can simply cancel them, and the answer is 1. Yes, but we're not there yet. Okay? I'm just trying to show you something real quick. Now, if it's a subtraction problem, though,